Hi, this is Rick Kensel with Coburn Supply, bringing you another tech tip. Many techs have read that you can measure the capacitance under a load by calculating the amps and the voltage of an operating system. The formula is easy. It's 2650, which is a constant, times the amps divided by the volts, and that gives you the operating capacitance. The problem with this is, amps and volts of what? The formula should read amps of the start winding and volts measured across the run capacitor. Maybe you'll read it as Herm and C on the run capacitor. So maybe you've checked the capacitor with your handy dandy 9-volt capacitor checker, but the compressor still seems to be dropping out on occasion. Maybe the capacitor is breaking down under a higher running load. Let's check the run capacitor while the system is running. First, this should be done only by a qualified technician, and as always, safety first. Take an amp reading of the start winding. This should be the wire that runs between the S terminal on the compressor and the run capacitor. It might be marked Herm. Take a voltage reading across the terminals of the capacitor, C and Herm. The voltage reading will be higher than line voltage, but it should not be higher than the voltage rating stamped on the capacitor, typically 370 and or 440. Alright, for example, let's read 244 volts across the contactor. You might read 362 volts across the terminals of the run capacitor. This is called back EMF. This is the voltage that's generated on the start winding of the compressor while the compressor is running. You might measure 5 amps on the start winding. The rating stamped on the capacitor is 35 microfarad and 370 volts, with a tolerance of plus or minus 5%. Sometimes 4%, 6%, or 10% can be read on the capacitor. A 440 volt capacitor can always be used to replace a 370 volt capacitor because this is the storage capability of the capacitor. It can hold up to 370 volts or it can hold up to 440 volts. The formula again is 2650, that's the constant, times the amps of the start winding divided by the voltage across the capacitor. Let's plug these numbers into the calculator to determine the operating capacitance. 2650 times our amperage of 4.75 is 12,587. And then 12,587 divided by our voltage of 362 equals 34.7 microfarads. This capacitor is producing 34.7 microfarads under a load. Next, we check the capacitor tolerance again, and it shows plus or minus 5%. Plus 5% of 35 is 1.5. 35 plus 1.5, or 36.5 microfarads would be the high end. Minus 5% of 35 is 33.5. So if the calculation falls between 36.5 and 33.5, the capacitor is operating properly. Our capacitor is reading 34.7. The voltage read across the capacitor was 362 volts, and that is below the 370 volts this capacitor can hold. If your capacitor falls outside of these parameters, tell the customer it's operating out of acceptable tolerance. Saying it's bad leaves it open for argument for a lesser technician that doesn't understand that this capacitor could be damaging the compressor windings. We hope this video has helped you sharpen your tech skill, and as always, thank you for partnering with Coburn's.